Engineering. I am Dr. Kavita, Assistant Professor of Computer Science, Mother Teresa Women's University, Kodaikanal. In this video, I am going to discuss some size factors influenced during software development and maintenance. In this topic, it involves level of efforts devoted to software development and maintenance, project size categories, and how programmers spend their time during software development and maintenance. First one is total effort devoted to software. So, in this topic, first let us see in the initial stage in the year 1980, the total amount spent on all aspects of computing in US is 5% of GNP. Then later it was estimated 8% in 1985, then 12.5% in 1990. Now it is in 2024 it is 9.3%. It includes the expenditure on software, IT services, cloud computing, etc. So, the current demand of a software technologist exceeds that available supply. The supply may be from 7.5 lakhs to 20 lakhs people in 1990. So, the major goal of software engineering is to provide tools and techniques to increase the productivity of the available software engineers. So, look at this picture, this graph that represents the ratio of expenditures for hardware and software spent during software development and maintenance. See, in 1960, the ratio was 80/20, which means 80% spent for hardware and 20% spent for software. Then later it was reversed, like 20/80. 20% is spent for hardware and 80% spent for software. Then it is in 1990, the ratio was 10/90. 10% spent for hardware and 90% spent for software. Because of decreasing cost of hardware like transistors, integrated circuits and VLI. So, one side the hardware cost is drastically decreasing, on the other side the software cost is drastically increasing along with the personal cost. So, this picture that represents the efforts devoted to hardware, expenditure of hardware and software during software and development and maintenance. Then next topic is distribution of effort. So, the total lifespan of a software product is discussed in this topic. So, it includes two things: software development and software maintenance. Software development, that for developing the software we spend 1 to 3 years duration. The duration of software maintenance is 5 to 15 years. So, the distribution effort between the development and maintenance is 40/60. So, 40% effort goes towards development and 60% goes towards maintenance. So, here the maintenance activities involves the following things: 60% for enhancing the capabilities of the software product and 20% for adapting the product into new environment and 20% for correcting the errors. So, the figure that indicates the distribution effort between the development and maintenance. So, initially it was 40 to 60, 40 spent for development and 60 for maintenance. Then later it was 30/70, 30 for hardware that is for development, and 70 for maintenance, and then it can be reduced up to 10 by 90. So, 10 for development and 90 for maintenance. So, during software product development, the distribution of effort estimates 40%, that can be used for analysis and design. Then 20% is for implementing, debugging and unit testing. Then 40% is used for integration and acceptance testing. See, look at this picture. In this picture, it clearly represents the testing that consumes half of the development effort. So, the maintenance activities consumes more resources than development activities. So, the maximum effort devoted to software enhancement, that testing requires the half effort during software development. See here, the system testing, the analysis phase like system testing, enhancement and adaptation, that consumes 3/4 of the total life cycle effort. So, the implementation here, it requires less than 10% of total effort. So, maintenance cost is too high comparable with development. Then next topic is project size categories in software engineering. See, project size is a major factor which determines the level of management control, types of tools and techniques required on a software project. So, the projects are categorized based on number of developers, project duration and product size. This product size that can be measured by using lines of codes. It represents it as LOC. Then major categories of software product: trivial projects, small projects, medium size projects, large projects, extremely large projects. Let us see the concise part of each category. First one is trivial project. Here only one programmer can be involved in this project category. So, the duration of this project is 1 to 4 weeks time. The product size is less than 500 lines. So, the number of routines used here is 10 to 20 lines. So, subroutines means a set of code that can be used to perform some particular task, that is subroutines. So, this trivial project is developed only for personal purpose, that can be developed by the individual programmer. So, here small amount of formal analysis, like the formal analysis can be used to improve the software product development and maintenance and to remove the inconsistencies. But here in trivial project, it uses only a very small amount of formal analysis, and elaborate design documentation, test planning and supporting documents are required in this category. Then small projects, similarly like the previous one programmer can be involved. The project duration is 1 to 6 months. The product size is 1000 to 2000 lines. The number of subroutines can be used in this part as 25 to 50 subroutines. So, here the standard formal subroutine software engineering methods can be used to improve the development phase and product quality. The example of a small project is to solve numerical problems, medium size websites and student projects, etc. Here it requires little interaction among the programmers or between the programmers and customers. Then next project is medium project. See here the number of programmers involved in this category is 2 to 5. Duration of this project is 1 to 2 years. Product size is 10,000 to 50,000 lines. Number of subroutines used in this the category is 250 to 1000 routines. Here it involves formal software engineering methods for improving the product quality, programmer productivity and customer satisfaction. It includes assemblers, compilers, small management information systems, inventory systems and process control applications. It requires interaction among programmers and the customers. The example of medium project is complex websites involving multi-vendor API application program interface interactions and multi-tenant models, health information management systems, etc. The next category is large project. Here 5 to 20 programmers can be involved in this project category. Duration of this project is 2 to 3 years. Product size may be 50,000 to 1 lakh lines. Number of subroutines used in this category is 1000 to 2000 routines. So here large program interacts with other type of programs and software systems easily. The example is it includes large compilers, small time sharing systems, database packages, graphics programs for data acquisition and display and real-time control systems. Then final type, extremely large project. So here 2000 to 5000 programmers can be involved in this project. Duration of this project is maybe up to 10 years. Product size is 1 million to 10 million lines. 2000 to 5000 subroutines can be used. So it consists of several very large subsystems and involve real-time processing, telecommunications, multitasking and distributed processing systems. Example of this category is air traffic control, ballistic missile defense and military command and control systems. Next, how programmers spend their time during software development life cycle. So look at this table. See here the table that represents the task and effort to be utilized during the software development life cycle. Writing programs, 13% can be utilized for writing programs, 16% for reading programs and manuals, then 32% effort can be taken for job communication, then 13% involved for personal work, then 15% for miscellaneous, then other than the duty, then 6% spent for training manuals and the 5% is for spending time to check the mails. Okay, in 1964, Baden of Bell Labs, they conducted a study with 70 programmers to determine how they spend their time effectively, how much time, how much effort they can be taken by the programmer can be analyzed in this study. The result was illustrated in this table. See here the programmer effort is 13%. Assume that totally 260 working days per year. Here we just assume that per week 5 working days can be taken per week into 52 weeks per year. So 5 into 52 is 260. 11 paid holidays, 15 paid vacation days, 5 days of sick leave and 3 days for jury duty, extra vacation, etc. So the results that may be 34 personal time, which is approximately 13% of 260. Similarly, taken 1 hour per day for coffee break, personal phone calls, and visit to the restroom plus 13 days travel time resulted in 39 days, or it may be 15% miscellaneous time. So, major reasons for understanding the cost of the failure of software product is accounted to 39% overhead time for programmers, like 13 plus 15 plus 5 plus 6 is equal to 39. Then failure to account for 48% of time spent in job communication and reading of programs and manual is 32 plus 16 is 48% of effort. So, this is another view of same aspect by Boehm. They conducted a study by using two different projects are illustrated in bar chart. Totally 40% of project effort involved in various categories such as reading, reviewing, meeting, and fixing this part, fixing the software product bugs. Then next topic is quality and productivity factors. See, this is the main important indicator. Software quality and productivity can be improved by improving the software development process. So, the development and maintenance of a software product are usually it is a very complex task. There is a difference between fundamental difference between writing a small program and software product. Developing and maintaining a high quality product requires technical and managerial skills. So, these are the factors influencing the quality and productivity: individual ability, team communication, product complexity, appropriate notations, systematic approaches, change control, level of technology, level of reliability, problem understanding, available time, required skills, facilities and resources, adequacy of training, management skills, appropriate goals, rising expectations, and other factors. Let us see the factors one by one. First one is individual ability. It is a prime factor in quality and productivity of software. So, production and maintenance of software products are mainly labor intensive activities. So, there are two aspects of ability. One is general competence, that is general competence of the individual. Then next one is familiarity of the individual with the particular application area. So, here familiarity, if there is any lagging in the familiarity of application area, means automatically that research the software project will be with a lower productivity and it leads with a poor quality. While we consider a large project means there may be number of programmers size may be large. So, the individual productivity will be average. When we consider a small project, that the individual ability is very sensitive. So, here the software engineering tool helps the programmers to work more competently. Then second factor is team communication. Generally programming is an individual activity. In large projects, programmers need to discuss the exact details of their work. Many programmers have low social needs and prefer to work alone. For that reason, they misunderstand their roles and often they commit mistakes. So, communication among programmers must be improved. If the product size increases, complexity of interactions among program components also increases. As a result, the programmer productivity will be decreased. So, from Brooks' observation, the communication path can be measured by using the formula that is n into n minus 1 by 2. That n that indicates the representation of number of programmers. So, increasing the number of team members from 3 to 4 to 5, that increases the number of communication path. That depends on the number of programmers. The path may be 3 to 6 to 10. So, according to Brooks' law stated, adding more programmers to a late project may make it later. Then next category is product complexity. There are 3 levels of product complexity: application programs, utility programs, system level programs. Application programs, it includes scientific and data processing routines that can be written in high level language, maybe C, COBOL, Fortran, C, C++, Python, Java, etc. This application program has the highest priority. So, it can be produced at a rate of 25 to 100 times of system programs. Then utility program, it includes compilers, assemblers, linkage editors and loaders that can also be written in high level language or assembly level language. So, it can be produced at a rate of 5 to 10 times of system programs. The next system level programs, it include data communication packages, real time process control system and operating system routines. It may be written in high level language. The system level program has the lowest productivity. Okay. Then appropriate notations. Appropriate notations means the good notations that clarifies the relationship and interactions. It provides the way of communication path among project personnel. So, programming languages provides a compact notations for the implementation phase of software development. Systematic approach. So, in obviously in every field there are some certain accepted procedures and techniques. So, this accepted procedures and techniques will benefit the software development. Here there is no universal standard to develop software engineering. So, single approach to software development and maintenance will not be sufficient for all situations. So, we have to consider a combined approach to develop a software and maintain a software. Then change control. So, flexibility of software is a great strength in software engineering. So, the requirements to change may occur due to poor understanding of the problem, changes in hardware software environment or external economic or political factors. So, notations and procedures can be provided to trace and assess the impact of processed changes. So, plans for change control must include in software project planning. The next factor is level of technology. It is changing rapidly. So, the factors involved in this stages are, first one is programming languages. So, which can be used to improve the facilities of data definition, data usage, user defined exception handling, concurrent programming, etc. Then next level is machine environment. It has set of hardware and software facilities for development and maintenance. Then programming practices. It involves systematic analysis, design techniques, appropriate notations and structured coding. Finally, the fourth level that includes software tools. Then level of reliability. So, every software needs a basic reliability, but extreme reliability needs great care in software development life cycle. High reliability can be achieved by taking great care during analysis, design, system testing and maintenance. So both human and machine resources are required to increase that reliability. Obviously, too much reliability causes decreased productivity. That productivity that can be measured by using the formula lines of code divided by programmer spent effort per month. Then problem understanding. Understanding the nature of problem that can be considered. If there is any lagging in the understanding nature of the problem, means automatically the entire software product phases will be lagging. So we have to the programmers and the customers must have interpersonal skills to deal with the requirements and planning. Sometimes customer may not understand the problem nature. So for that reason, sometimes it fails to understand the nature of problem definition and system definition. On the other side, the software engineer is also don't understand the area of application, because maybe the engineers they may not have a sufficient knowledge about that particular application area, or they may not have interpersonal skills. Careful planning, customer interviews, task observations, prototyping, user manuals, and precise product specification can increase the problem understanding of both customer and programmer. In this video, we discussed about some size factors influenced in software development and maintenance, project categories, and how the programmers spend their time during software development life cycle, and the factors influencing software development and maintenance. The remaining portion will be covered in the